We are required to simplify this expression. Now, there are a few things that you need to always remember when working with expressions, exponential expressions, such as these, for instance. The first thing that you need to always do is to make sure that all your base numbers are prime numbers or products of prime factors. Now, in this case, 2 is a prime number, so we can skip that step because all our base numbers are indeed prime numbers. The second step would be to get rid of any brackets. Now, we don't have any brackets where you would typically use the third exponential law. Now, that would be something like, let's say, for instance, one of these base numbers was 4. Then you would write, let's say, 4 to the power of a plus 1. Then you would write the 4 as 2 squared in brackets to the power of a plus 1. Because that is just converting the 4 into a product of prime factors. But then, using the third exponential law, you'll multiply all the exponents inside the brackets with all the exponents outside the brackets, and that will then give you 2 to the power of 2a plus 2. So that step of getting rid of the fractions would then come next. But our expression that we have over here doesn't have any brackets anyway, so we can also skip that step. But then we need to get every one of the exponents to have its own base number. And the logic behind that is making use of the reversal of the first exponential law. So let's say, for instance, you have x to the power of 2 times by x to the power of 3. We know that it is equal to x to the power of 5 because you can simply add the exponents since the base numbers are exactly the same and these base numbers are being multiplied. But what we are looking at in questions such as the one that we are busy with is not so much getting the answer of 5, but writing this as x to the power of 2 plus 3. Because what we have there is a plus or a minus of exponents. And what we simply do then is to give every one of those exponents the same base number coming back to the left-hand side. So you just literally give every one of the exponents the same base number. And that is where we're going to pick up on this question. We are going to write the first expression as 2 to the power of a times by 2 to the power of 1. Then minus 2 to the power of a times by 2 to the power of minus 1 divided by 2 to the power of a. So that is a very important step, making sure that every one of the exponents has the same base number. And then from here going forwards, there are different schools of thought. What you can do next. My personal feeling is keep your numerator and your denominator in expressions such as these separate from each other, and also keep your different base numbers with different exponents separate from each other above and below the line. But in this specific instance, what we have is a 2 to the power of a, which is subtracted. There's a minus between two terms, either above or below the line, which immediately indicate that you must factorize. And we'll take out that 2 to the power of a as a common factor, which means what we will have left then is 2 to the power of 1 minus 2 to the power of minus 1. Remember, those two terms just basically go outside the bracket, and this whole thing is then divided by 2 to the power of a below the line. And then you'll notice that those two can actually cancel. And what you are left with now is just numbers. 2 to the power of 1 minus 2 to the power of minus 1 is a half, and 2 minus a half is 1 and a half. And there we have the final answer to this expression.